Hello everyone, so today I'm going to be teaching you basically how the internet works. I figured that a lot of people wouldn't know how the internet works. Maybe some people thought about it and stuff like that. I did make a previous video explaining the same stuff, except I made some errors, so I took it down about like 2 hours later when I realized what I did. So yeah, if you saw that one, you may see this one too and you'll learn more correctly. But basically, I want to tell you guys how the internet works. How do you communicate with a server such as YouTube? How do you know that that's YouTube? I mean, like, how does the URL address youtube.com do stuff? I mean, you probably use the internet all the time, but how often do you do something on it that you actually understand? I mean, sure, you may understand, okay, well, JavaScript allows me to do this so that the button works on the website. Okay, that's great, but that's not how the internet works. That's how your browser interprets code. Awesome. Good for you. But it's not the internet. The internet's pretty complicated. There's addresses that you've probably messed with but never really understood how they worked. There's port forwarding. There's ports to start off with. There's all sorts of crazy stuff that goes on. Handshakes, different types of transmissions that go on. Basically, why you need a firewall, what your routers do, stuff like that. It all actually affects how you go onto the internet. So, yeah, we're going to be covering that question today before we move on to Java and stuff like that again. So, yeah, let's get started, I guess. Select a brush up here. Hopefully this isn't too bad. Okay, size. Sorry, 1 second. Okay, that works fine. So, I guess to start off with, I'll tell you guys what an IP address is. Now, an IP address, just literally IP, stands for Internet Protocol, and then you have basically your IP address. Now there are two different types of IP addresses. There's one that's public to the internet, and then there's one which is, well, I guess not really public to the internet, but we'll get into that later. And then there's one that's internal and really only matters to your network if you have like a router with multiple computers in your house. That's what an internal IP address is. But an IP address is pretty simple. One you may be familiar with, you may have seen it before or heard of it, is 127.0.0.1. And I bring this up for multiple reasons. First off, it shows you the syntax for an IP address. And by the way, this is IPv4, Internet Protocol version 4. There is another version called IPv6, but we won't get into that. It's not even really used by anyone at this point. Soon, hopefully it will, but yeah. Anyways, first you have four numbers. You have 1, 2, 3, and 4 numbers. And this identifies your computer. And this number in particular, 127.0.0.1, is special. Unless you change it in your network somehow, there's probably a couple different ways to do it. That number identifies your own computer. However, if you did it on another computer, it wouldn't go back to the first computer you started on. 127.0.0.1 points back to your computer, and it always will. There's also some other ones. There's like actually a rule, unless you again set it differently on your network. 127.0.0.1 will look at your computer. So if you ever wanted to test something with sockets in programming or something like that, you could have it so it would connect to your computer and never go out on the internet for test, so that you could actually test it without worrying about anything. So it's usually used for debugging. I mean, it's a good way to make sure that when you're on your computer that if you're going to run something that involves IP addresses, that you specify that it's your computer. Some other things will also, instead of saying 127.0.0.1, it'll say localhost, which is the same thing, but it's a word and not a number. But yeah, that's pretty much what that is used for. Now, why are IP addresses significant? It has the word internet in it, so obviously we're on the right track. This does relate to what we're talking about. But what's important about it? Well, the internet is huge. I mean, gigantic. And a lot of websites, like Google, for instance, if you log into your Gmail, it'll store something on either its side, its server side, or your side, client side, which identifies your computer and makes sure that they remember you. Now, if they do it to you, they usually have something that they put on your computer that identifies you specifically, and then they put it in their computer as well, and then match up, and they're like, okay, it's this person. They don't have to enter in their data again. But there are some other cases where it just looks at your IP address, particularly in things that ban you. It's usually your IP address that gets banned. For example, Ventrilo servers, if you've ever used that for whatever reason, for those of you who don't know what it is, it's basically like a voice conference application. That will ban people based on their IP address. And the reason that is because an IP address is unique to you. Other than 127.0.0.1, everything else is different. If you had an IP address like 152.9.826, that IP address is unique to your network. That will lead to your router or to your computer directly if you do not have a router. And these IP addresses are actually dished out by your internet service provider, or what most people will call it, an ISP, short for internet service provider. And so an IP address is pretty important. I mean, if you ever need to find out an individual computer, you need an IP address. That way you can figure it out, like which one you're communicating with, which is really nice for security and just makes things really smooth on the internet. So that's awesome, but if a computer knows that another computer has this IP address, how does it communicate to that computer in the first place? Okay, it knows where it is, but how does it send the message? I may know where my friend lives, but that doesn't mean I can automatically know his phone number, call him up and start talking to him. So there's another thing which is on your computer called a socket. Now, a socket is pretty awesome. Imagine your computer is this thing right here, this little box, and then over here on the other side of the world is Google's gigantic server with like a halo because it's so awesome. It's like godly. And you want to say, hey Google, I want to talk to you, and I have your IP address. How do I send a message to you? Well, most websites will have a port open, something that looks like this. And a port is basically a number on the computer which is linked to the IP address. It says, okay, you want to go to this computer, but where do you want to go on this computer? Well, we have all these ports, and it's any port from 0 to 1024 are reserved for privileged users, admin access. Usually for services that are running, they're like set to run certain services. Anything greater than that, they're pretty much, for the most part, freestyling. But websites usually reserve port 80 or port 146, don't quote me on the last one, for HTTPS. But port 80 is for normal internet access. And so Google, for example, has port 80 open, so anyone can connect to it. There's no, like, it's not filtered. It just says, if you want to connect, go ahead. And so you will also open a port on your computer probably, or not open a port, but you'll send messages through your port on your computer, which it actually doesn't even have to be the same one. And then it'll say, okay, cool, so I have all this information behind this port, let's send it out. And then it goes boom, across the internet at light speed into Google. And then Google does its fancy algorithm stuff, and then goes, okay, more information, and it goes back to you. And then you're like, okay, cool, I want to go to this link. And then you go to another web server that's probably down here. And so that's basically how you communicate using ports. Now, a socket is when you bind a service to a port. So port 80, if it has something running on it, like a web server that Google does, it becomes a socket instead of a port. And if you see something like 127.0.0.1 and then colon, that if you type something like that into your browser, anything after the colon it'll look for as a port number or a socket. So we could say port 80, which is the default because most websites use that. So it'll go to port 80 or whatever you tell it to connect to, maybe 8008. And that is how it would be written. But again, if you bind a service to something, a port, it becomes a socket. So a lot of people will use them kind of interchangeably, but they are two different things, but still kind of the same. So it does get confusing, but remember, a socket is bound to something. You bind a service to a socket, and a port is just something that's there, it isn't used. So if they said, oh, they have port 80 open on their computer, that doesn't mean that there's a service running on it, that just means that it's there. If they said I connected to port 80 and there was a web page there, it usually means that they're running like Apache or something like that, some sort of service to handle connections. So awesome. Okay, we know how you would send a message to a computer using ports, but we don't know how that actually does it. How do you send a message from one port to another? There has to be more to it, right? Well, there is, and it's where it gets pretty complicated. There's two different ways to do this. There's UDP, and we'll go over that later, but it's not going to be too important to this tutorial. And then there's TCP. Yeah, okay. So here's basically what they each mean and what they do. What's the difference? UDP stands for User Datagram Protocol, and it's less safe, and I'll explain why after we go over TCP. But basically, UDP is not used that much because of how it works, and it'll be easier to explain after TCP. TCP stands for Transmission Control Protocol, which is pretty much the dominant of these two. You may hear them referred to like UDP-IP or TCP-IP, which is like using TCP via IP. Use TCP protocol and in Internet protocol to send messages. That's basically the relation. Now TCP is pretty awesome. I am going to clear this out real fast because it'll make things easier because I'm going to have to redraw a bunch of stuff. So let me pause this real fast. Alright, so with TCP, if you have a computer here, let's say it's yours, and then you got this big server over here again, there's actually a way to say, hey, I want to connect to you, let's start sending data. So usually the desktop's going to connect to the server, and it's going to start transferring what's called a handshake to initiate the connection. So first you're going to send something called a packet. Now a packet, for a quick little explanation, is basically like an envelope. And let's actually make it look a bit better. So, okay, something like this. It's an envelope which has inside of it the data you want to send, the message. It also has where it came from, like normal mail, so you can return to sender. And so it doesn't work like that on the internet, but it has where it came from. And then it also has where it needs to go and which port it needs to go to. And so this packet will have the information, and the web server will take that envelope or packet, open it, look inside, read what's ever in it, and then send its own packet back in response to whatever was in the first one and whatever the server's programmed to do. So when you send your first packet, this is called a SYN packet. S-Y-N. And this is short for sequence. And that's how the connection first starts. Next, you have your server, or the person who receives the SYN packet, and they send an ACK packet, which is acknowledgement. They acknowledge that you want to start a connection. You then, to verify you want to start the connection fully, you send a third packet, which is the SYN-ACK, the sequence acknowledgement, saying, I acknowledge that now we are sending data to each other. And that's all fine and dandy. Now you'll start sending data back and forth. And that's basically how that works. Now, the way that TCP works when it does this, which by the way, it's really the only one that kind of does that, because it has to go in a certain order. TCP sends everything like a river. Let's say this is a river here, with all of its nice little bends and curves. Okay. And we have these little waves, and everything follows this current that goes downstream. And so your packet here goes, okay, let's get on this river, and it flows all the way down here to this computer. And that means that because everything goes at the same speed, this packet will go before the second packet that you want to send, which means that everything kind of goes in order. It will be received at the same time because it takes the same river to the server over here. And UDP does not do that. UDP also does not use this handshake up here, which is actually not finished, and I'll go over that in a second. But UDP will use rivers, but it uses multiple ones at a time. So this is packet 1 and this is packet 2, and they'll reach the same spot. But with UDP, let's say this is the server over here and these are your packets. So this is packet 1 and packet 2. You may send packet 1 first, but let's say packet 1 takes this route. And then packet 2 just takes this route. Packet 2 will make it before packet 1 does, and so the data is going to be received in the wrong order. Now, that's the downfall of the UDP. And it's still used for some things, not really much, but yeah, that's why UDP isn't used, and that's the difference between that and TCP. So we're not going to really talk more about UDP in this video, but we're going to talk a lot more about TCP. So let's get rid of all this stuff down here. We don't need this river or anything. Now that we have this SYN-ACK thing back up here, the handshake, there's actually a way to terminate it. Now, sure, if one of these computers went off, the connection would be dropped because there'd be nothing to send data to. But well, if you want to finish the connection, which is usually what happens, you would send another packet. And this one is called the FIN packet for final. So that's a FIN packet. Now the server would then send another packet, which is called the FIN-ACK. So FIN-ACK, which stands for final acknowledgement of the connection. But it doesn't just stop there. After it sends its FIN-ACK, at the same time, or right afterwards, it'll send another packet, which is called the fin packet. Because it'll want to say, okay, we acknowledge you want to finish, but we also want to finish, so we need to make sure that we're both going to finish it. That way no one can finish it for us. And then you'll go, okay, I understand, and then you'll send another FINAC packet, which is where this diagram gets really complicated. But that is basically how TCP will function. And this is all done via ports and IP addresses, so it knows where to go. And bam, connection was initiated, data was sent, connection ended. All done, thank you. No need to congratulate me. I'm an awesome computer who has access to the internet. So cool. Well, what stops me from being able to do this to any of your guys' computers, connecting to it and sending data? Well, there's a thing in your routers, most routers do this, almost every single one of them, in which it listens to this, it adheres to these rules called Stateful Protocol. And essentially, if it gets a packet that does not say which computer in the network it wants to connect to, it'll just drop the packet and say, well, I don't know who this goes to, sorry, bam, drops it. And so in the packet you send to a server, it has more than just your IP on it. It has your external IP and your internal IP, as well as the IP that's getting sent to. That way it knows which computer it's going to. Or at least you'd think that's how the packet would work, but it doesn't. The packet has no information like that, because that'd be a really big security error. What if someone had you go to a website without you knowing it did this and grab both your IPs, then they can access your computer whenever? That'd be horrible. So instead of putting it on the packet, they're like, we're going to be smart about this, and the routers that listen to Stateful Protocol will actually have these little tables and columns in here. And I'll say, okay, this is computer 1 in our network, 2, 3, and 4. 1 connected to Google, this one connected to YouTube, this one Facebook, this one I don't know, Yahoo. And so if Yahoo tries to send a packet saying, okay, yeah, you signed into your email, it's going to go to the router, and then the router is going to say, well, this person didn't connect to you, this person didn't, but this person did. So it sends the information to this computer instead of the other ones. And this stops like me going, hey, I have your IP address, and just going in and just connecting to every computer, because I don't have your internal IP address, so I can't connect to your individual computer. And so that's the importance of a router as well. Now, if you don't have a router, you are kind of vulnerable to stuff, but chances are you have a router and you don't really have to worry about that. But then there would be nothing to really stop connection attempts. Now, there's not really much to talk about in the internet other than this other thing, which is called TTL. Now, TTL stands for time to live, and basically stops packets from traveling everywhere in the entire internet forever. And let me clear this out to try and explain it a little bit better. Alright, so when you send something to a website via its IP address, TTL, time to live, is on every single packet. All this data, by the way, is held in a header, which is something that is predetermined in size, has all of the information up here, and that's why it's only so big. And then all your main information is down here. So in the header, there's your IP and all that stuff. But there's also TTL, which can be a couple numbers. I think the max is like 255. But essentially, it means this is what number of computers I can visit in order to get to my destined computer before we drop the connection. And so usually you'll have a router, and it will hit a packet from somewhere on the internet, will come to yours and be like, hey, I'm looking for this guy, where do I go? And your computer will be like, oh, it's over here. And you'll be like, okay, thank you. And this router will be like, oh, it's over here. And then you'll eventually get to your server over here. Now, each time it visits a router, though, your packet, let's say it has 15 on it. Once it visits my router, it'll go down to 14. And then it'll go down to 13. And so forth. But once it hits 0, whatever server gets a packet that has 0 on it, it's going to say, whoa, 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 nope, you failed at connecting. The server was over here and it didn't work, so you gotta go back. And the reason this is because you don't want a packet just wandering around the internet forever. It's bad. It's just bad. Imagine if everyone would send out a packet, didn't meet its destination, and just starts going around to every router at all times. There's so many people using the internet. If a packet kept flying around forever, and people's packets did that whenever a computer wasn't there, like if it changed IPs because it wasn't located in the same place anymore, all hell would break loose. I mean, you'd have all these things clogging the internet. And so TTL says once you get to 0, you drop the packet and it's no longer on the internet. It doesn't exist. You delete it. And it stops things from slowing down. So awesome. Now, before we leave, there's one more thing I need to cover, which is DNS. And DNS stands for Domain Name System. And a domain name is YouTube.com, Facebook.com, Yahoo.com, and so forth. And those actually are not what the computer's called. Like I said, you need an IP address. YouTube.com is not an IP address. It doesn't fit the criteria that I told you in the beginning. So how do you connect to YouTube? Well, your DNS, which is usually provided from your internet service provider, will take the name, go through DNS, and go, okay, it's actually this IP address, puts it on your packets, and then sends it on its way, and you connect to the server. The reason that this exists is because it's really hard to remember IP addresses. It's easier to remember names than it is to remember numbers. And you can also get a custom name. If you really wanted to, you could buy a domain name for your computer that would go to your IP address. Now, whether or not you have a service running on it is up to you, but you can do that with DNS, so kind of cool. Although there's really no reason to do that, and it's probably bad. But DNS is the main way that the internet got so big. If people had to rely on numbers to memorize where they were connecting to, it probably would have never gotten big, because who wants to do that? That's not cool, bro. So DNS is the reason that everything else is so easy for you. And now you know the basics of the internet, how all of it does its cool little stuff, and so forth. And we'll go on about more things later on in other videos if a lot of people like this. So yeah, don't worry guys, I'll still be doing programming videos. I just thought that some people might want to watch this. And sorry I haven't been making videos for a while. I'll get to that soon. We'll do more of them soon, and so forth, blah blah. Subscribe, comment, like. I'll see you guys later.